Hello students, welcome back to the episode 2 of Past Thavanu Panchamrut. Myself is Kunal Pandya from the HBK group of schools, and today I am going to present Past Thavanu Panchamrut in collaboration of HB Kapadia group of schools and GSTV. So in our previous episode we saw some MCQs based on understanding. So I will show you one more MCQ based on that topic. So one more question, which of the following is true for a real transformer? This is a understanding based question. Which of the following is true for a real transformer? See, the question is real transformer. In our textbook it is given ideal transformer. So there are two types of transformers, real and ideal, other than step up and step down. So for a real transformer, see, practically whenever there is an input for a transformer and output for a transformer, always output is less than the input, because there are too many losses of transformer. See, 2-mark question can be asked from this topic also. Write down the losses occurred in transformer. So answer to this question will be Pi will greater than Po. It means input power of a transformer is always greater than the output power. Now let's see next question, next section of the MCQ actually. It is application based MCQ. This is a very tough part of MCQs. 16 number of questions will be asked, and per question don't dedicate more than 1.5 minutes. Okay. So the first question is, the network shown in figure is a part of circuit. This is a part of a circuit which is given to us, and we want to find out potential difference between point A and point B. Once again, we want to find out potential difference between point A and point B. Applying Kirchhoff's second rule, if we start from point A, if we are going along the direction of current, then at first resistance is there. So I into R, the value of current is 2 ampere, 2 into 2 becomes 4 volt. So therefore voltage lost by resistance will be 4, that is minus 4. So at first here you have to write minus 4, then voltage will have, it is having a 12 volt battery, so therefore minus 4 plus 12 becomes plus 8, and inductor multiplied by the decreasing rate of the current, that is 5 millihenry into 10 raised to 2, that becomes 0.5, and hence the answer will become 8.5 volt. Okay. Let's see the next MCQ. This is again from Gujarat board or Gujarat examinations. For an AC given by, that is ACC, they are not mentioning that whether it is alternating current or something like that. AC stands for alternating current. Okay. So for an AC given by I is equal to 50 cos of 100t plus 45 degree ampere. See, here ampere is written. Sometimes they write milliampere, and you solve the MCQ according to ampere and you will lose the marks. So be careful. See, the unit given is ampere, and you want to find out the RMS value of this current. You want to find out RMS value. So the formula of RMS is IRMS is equal to Im by root 2. Im, see, the this 50 given over here is called Im, that is the maximum value of current. So if we divide this maximum value of current 50 divided by root 2, this 50 divided by root 2 will give 25 root 2. So the answer will be 25 root 2 for this question. Next question is based on chapter number 14. It is based on PN junction diode, and here is a we can say they are trying to confuse you people with some extra data. Let's see. The forward and reverse bias resistance of PN junction diode is forward bias. See, when the diode, this is called a diode, this is a PN junction diode. In forward bias condition means what? When P is connected with positive, N is connected with negative, or we can say P is connected with higher potential and N is connected with lower potential. At that time the resistance is 20 ohm, whereas in the case of opposite, that is in reverse bias condition, resistance is 2000 ohm. So once again, when the current is flowing in this direction, the resistance is 20 ohm. When the current is flowing in this direction, resistance is 2000 ohm. We want to find out how much current flows as shown in the circuit arrangement. We want to find out the value of current. So again, it is an application based MCQ. You have to apply your knowledge, you have to apply the formula. See, when the current, when this diode is connected in this way, like P is connected to a higher potential, N is connected to a lower potential, then you should know that it is in forward bias condition. And in case of forward bias condition, the resistance is given to be 20 ohm. This 2000 ohm given over here is to confuse you people. Okay, so don't see that data. Just extract this one. 20 ohm is the resistance resistance is the effective resistance of this circuit. So 5 volt here, 20 for this PN junction diode, 100 volt is for the external resistance. Now tell me, see, we can say 100 ohm plus 20, that becomes 120 ohm. So total resistance over here will be 120. Potential difference is phi. We can say V is equal to IR. Therefore, I will be V by R. Do the calculations in your mind. I is equal to V by R. Therefore, voltage is phi divided by resistance is 100 plus 20. That is phi by 120. And after calculation, you will get answer to be 1 by 24 ampere. So, as we do in our episodes, I always give you some mnemonics in order to remember the formulas. Okay, so here one more mnemonic are there. See, there are 3 sisters. You can remember this way. There are 3 sisters, Bina, Pina and Meena. Okay, remember 3 sisters, Bina, Pina and Meena. This will help you to remember 3 different formulas which are very important. One is tau max. Tau max means it is the maximum torque acting on a rectangular coil when it is kept in magnetic field. Also, this formula is applicable for galvanometer. So, tau max is equal to Bina. This is the formula where B stands for magnetic field, I is electric current, N are the number of turns in a rectangular coil, and A is the total area of a coil. Second one is Pina. See, remember this Pina and Meena are quite confusing. P stands for pole strength of a magnet. Okay, pole strength of a magnet is indicated by P, and it is equal to I N A. Okay, where N are number of turns per unit area, unit length, and A is the total area of the coil. Meena, M stands for magnetic moment, I stands for current, N for number of turns, and again A for the area of the coil. I am giving you one more mnemonic, that is this one. This is from chapter number 3. Some students quite feel, they just forget this formula in examinations. So therefore, you can remember this formula like this. I is equal to Ja. J stands for electric current density, A is the area. So you have to remember like this. I Ja Avni. Okay, imagine I Ja Avni. Where you have to call Avni? To have a tea with Anil. Anil by T. So you can remember this way. I Ja Avni, Anil by T. Okay, you can also remember like this way. A-N-E-L means Anil. You can remember like N-E-L and Neela or L-E-N and Leena. Whatever you like. N-E-L, Neel. Whatever you like. But remember this formula. I Ja Avni, Anil by T. So, we'll be back after a short break. Thank you. So students, welcome back. So in previous section we saw MCQs based on application. Okay, they were application based MCQ in which you can solve the MCQ and find out the answer. But in such type of questions like analytical and combination type of MCQs, you have to go through all the options. You cannot just find out the answer with the help of question. Okay, you have to go through all the options and you have to figure out which option is correct. So the first MCQ is if electric dipole is placed in a non-uniform electric field. See here, electric dipole is kept in non-uniform. See, electric dipole can be kept in uniform magnetic electric field. A magnetic dipole can be kept in non-uniform magnetic field, and a magnetic dipole can be kept in uniform magnetic field as well. So there are 3-4 probabilities of such type of question. I am explaining the one, and rest you have to prepare yourself. So if the electric dipole is kept in a non-uniform electric field. So imagine somewhere there is a non-uniform electric field. Non-uniform electric field means somewhere there is a plus Q charge over here. Okay, plus Q charge is here and there is no negative charge over here up to infinite distance. So in that case, the electric field will come out from the positive charge and then the electric field will be non-uniform. The electric field lines will not be parallel. Okay, so such type of non-uniform electric field is there. Now, this electric dipole, consider this to be an electric dipole. Okay, this is an electric dipole and it is kept in a non-uniform electric field. That is, electric field, some lines are going in this direction, some are going in this direction, some are going in this direction. So if the dipole is kept like this dipole will undergo rotational motion. Okay, obviously, because see, if this is an electric dipole, one has to be positive charge, another should be negative charge. So if this is positive, this is negative, over here is a positive charge, as a result this dipole will rotate like this. So if the dipole is rotating, torque cannot be zero. Understood? Torque cannot be zero. Torque, we can say there is some torque acting on this dipole. If initially the dipole is kept like this, initially itself, if the dipole is kept like this, then the dipole will not rotate. So the probability is dipole can rotate if it is kept like this, or dipole cannot rotate. From that we can say torque may be 0, may not be 0. So for torque we have two probabilities. Two probabilities for torque. Torque may be 0, torque may not be 0. Okay, so from this we can say torque acting on dipole may be 0. See, torque acting on dipole is 0. That statement is correct, but not always. If there are certain conditions for the torque or acting on the dipole when it is 0. Okay, so the answer will be torque acting on dipole may be 0. Let's take the other option also. Resultant force on the dipole is 0. Resultant force, see, if the dipole is kept like this, initially it will rotate, and after rotating the dipole will move towards the positive charge. Okay, the negative part of the dipole will move towards the positively charged, and hence we can say the force is not equal to 0. If initially the dipole is kept like this in initial condition itself, then also the dipole will move. So in any condition force cannot be 0. Force will always act on this such type of dipole. So resultant force on the dipole is 0, that is not possible. Resultant force on the dipole may be 0, that also is not possible, because always some sort of force will act on the dipole when it is kept in non-uniform electric field. And about torque, we can say torque, if it is kept like this, torque will act and the dipole will move like this. And if initially the dipole is kept like this, no torque will act. So for torque, we can say torque acting on the dipole may be. So it depends on the condition, it depends on the orientation of dipole with the electric field. Next, select incorrect unit of self-inductance. In hurry, some people just select correct unit of the self-inductance, they just write down any option. So read the question carefully. The question is incorrect. So you have to see all the options. Okay, you have to go through all the options. I just said it's an analytical and combination type of MCQs. These MCQs cannot be solved like just reading the question and you are getting the answer. It is not possible. You have to go through all the options. So by going through all the options, we can say the unit which is incorrect for self-inductance is mho into second, because all of the other Weber per ampere is a unit of self-inductance, volt second per ampere also is a unit of self-inductance, ohm second is also a unit of self-inductance. Instead of self-inductance, if they have kept mutual inductance, then also the answer will remain same. There will be no change in the answer because the unit of self-inductance and mutual inductance are one and the same. Now, again coming to the mnemonic part, my and your favorite part, to remember the formulas, more you know, less you fear. The equation for intensity, see, I have written two equations for intensity because people quite get confused with the equations of intensity. So equation of intensity, intensity is defined as energy imparted per unit area in unit time. Okay, once again, intensity is defined as energy imparted per unit area in unit time, and that is equal to C. C is the velocity of light, and rho is the energy density of electromagnetic wave. We know that the light is in the form of electromagnetic wave and its density is called rho. So I is equal to E by AT is equal to velocity of light into density, that is energy density of electromagnetic field. So you can remember this formula as I is equal to EAT. See, I always eat 0. Okay, you have to remember this formula like I eat 0. Okay, if you remember that, then you can easily recall this formula in examination. I is equal to E by AT is equal to C into rho. Just remember, you have to write divided by A and T will be in denominator. Don't write I is equal to EAT is equal to 0, that will be incorrect. Once again, next formula, I is equal to PC and U is equal to PC. This question is there in electromagnetic wave. I is equal to PC, intensity is equal to PC, energy also is equal to PC. So there is a confusion here also. Intensity is PC, energy is PC, that is not possible. But P can have different meanings too. Okay, P can have different meanings too. Like I is equal to PC, in case of I is equal to PC, P is a pressure, and in case of U, P is a momentum. So you can remember this formula as I is equal to PC, I am Prem Chopra. Okay, remember, I am Prem Chopra and you are Priyanka Chopra. Okay, I am Prem Chopra, you are Priyanka Chopra. I have pressure, that Prem Chopra is having pressure, and you have momentum. That Priyanka Chopra is having momentum, she just run away to US. So I is equal to PC and U is equal to PC. These are the two formulas which are quite confusing, and I have tried to make it simple. Now coming to the part B, this was all about MCQs. I will be giving you some tips for these MCQs in our last episode. Now coming to the part B of, which is a very important part in fact of our question paper. Part B, in that we will be discussing about SA1, that is short answers 1. They are 2 marks questions. Okay, these are the 2 marks questions. Each question carries 2 marks. Total number of questions asked as previously discussed will be 12. There will be general options and you have to attempt only 8 questions. Okay, you have to attempt only 8 questions. Each question carries 2 marks, therefore 8 into 2 becomes 16. So we'll be back after a small break and we'll be discussing all the 2 mark theories. Welcome back after the break. So before break we saw essay 1 type of questions. There are 2 marker questions. Such 8 questions you have to attempt out of 12 and each carry 2 marks. So here I have presented 2 such questions, 1 theory and 1 numerical. So let's have a look on a theory type of question. This is basically a essay 1 type question, that is short answer 1 type, and it is a 2 marker question. So the question is explain Curie's law. See, some students, I can say majority of the students skip chapter number 5. Okay, the reason is its chapter is very large and just 2 mark questions is asked and it can go into the option. But I will suggest don't skip that chapter. Instead prepare some easy topics from this chapter, and one of the easy topic I have kept over here is Curie's law. So let's see, let's have a look on Curie's law. See, experimentally it was found that magnetization of a paramagnetic material is inversely proportional to absolute temperature T. See, while the inventions of magnetism was going on, many scientists were doing experiments based on solenoid. They were taking a large solenoid and they were just keeping inside a different type of materials, and they were finding out different properties of the material which was kept inside the solenoid. They were changing the magnetic field, they were changing the temperature, and they were trying to find out the magnetic properties of a given material. So Curie also did that. So experimentally it was already established that for a paramagnetic material, magnetization is inversely proportional to temperature. Curie found out that the magnetization is also proportional to magnetic field. So magnetization of a material is directly proportional to magnetic field and it is inversely proportional to temperature. This was found by Curie. Hence the formula becomes M is equal to CB0 by T. Of course, it was found by Curie, therefore C must be a Curie's constant. So M is equal to CB0 by T, or we can say CB by T. Okay, if you want to remember this formula, you can say CB by T. So M is equal to CB by T. Now, M is equal, see, we know that M is the magnetization which is given by the formula M is equal to chi into H. Here chi is called magnetic susceptibility. Okay, chi is called magnetic susceptibility. We can say susceptibility is what? It is a property of a material, that how a material behaves in presence of external magnetic field. See, there are 2 type of susceptibilities in our whole syllabus. One is electric susceptibility, another one is magnetic susceptibility. Both are unitless and dimensionless. So at first, let's see what is magnetic susceptibility. See, imagine 4 number of students are there. Imagine 4 students are sitting in presence of me, and I'm a doctor, I am a psychologist, and I am just hypnotizing those 4 students. So after some hypnotizing, if one of the student does what I say, then we can say he has got hypnotized with me. We can say his alignment of brain with me is more susceptible, or we can say he is more in alignment with me. Another student, if he is not doing what I say, we can say he is having low susceptibility. The other student which is doing exactly what I say, exactly opposite to what I say, then we can say he is having a negative susceptibility. And one of the student, if he is doing nothing, we can say he is having 0 susceptibility. So we can say susceptibility is a thing that a substance will behave in presence of external electric or a magnetic field. In general case, we can also say if you are more susceptible to disease, you are more likely to have corona. So in that way you can understand susceptibility. So here M is equal to chi H, where chi is called magnetic susceptibility. So if you put that value here, we get M is equal to C mu 0 H by T. After deriving this, we can say chi is equal to C mu 0 by T, where chi is called susceptibility. So susceptibility of a material can be changed. That was found by Curie. That was a great invention or discovery. Chi is equal to C mu 0 by T. That is, susceptibility depends on temperature. So we can change the susceptibility of material by just changing its temperature. That was a wonderful thing. We can also change the permeability as well. So this equation is known as the Curie's law, and C is called Curie's constant. For a paramagnetic material, both chi and mu are depend not only on the material. We can say chi and mu just not only depends on material, but also depends on temperature. This was established with the help of this equation. As the B0 increases, see from this equation, if we can say if B0 increases, or temperature is lowered. See, B0 increases or temperature is lowered, the value of M, that is magnetization, will increase. So we can say all the laws are having some limitations. Even Newton's law has some limitations. So Curie's law here also is having some limitations, and the limitation is beyond some point, beyond the saturation magnetization, Curie's law is no longer valid. So if we go on increasing the temperature, if we could just go on increasing the temperature, temperature increases, magnetization goes on decreasing, and at a given point, this magnetization will no longer be available. So this is the limitation of Curie's law. So whenever such type of question, any law is asked, you have to write the law, okay, you have to write the equations, and don't forget to write its limitation if you know and if it is given in our book. Now, one more essay 1 type of question, that is a 2-marker question. I have kept a numerical, I have kept a theory, we just gone through a theory, and now it is a time of numerical. So, in numerical, a long straight wire in the horizontal plane, see this diagram will not be given in your question paper, you have to imagine, you can also make the diagram in your answer sheet. A long straight wire in the horizontal plane carries a current of 50 ampere in north-south direction. So you have to practically imagine in your examination where the north direction is and where the south direction is. So imagine that this is the north. Over here there is the north direction and this is the south direction. So north and south are like this, and give the magnitude of B at a point 2.5 meter east of the wire. See, if you are taking north and south like this, compulsory you have to take east and west like this. You cannot take east here and west here. Okay, that is a general rule. That is a general rule of geography. So if north and south are here, then you have to take east here and west over here. So east is here, west is there, and the current is flowing from north to south. So imagine current is going in this direction. Okay, the direction of current is like this. And we want to find out magnetic field. Not only just magnitude, but also we have to find out the direction of magnetic field. Okay, we have to find out both direction and magnitude of magnetic field at a point 2.5 meter east of the wire. So imagine a point which is at a distance 2.5 meter from the wire, which is in the east direction. We want to find out the magnitude of magnetic field and the direction. Let's see the magnitude first. See, the formula for magnetic field due to an infinitely long wire at a distance r is given by B is equal to mu 0 I by 2 pi r. Okay, this is the straight formula which is given in our textbook. भगवान का दिया सब कुछ हमारे पास है. We can say like that. I है, yes, we are given the value of I, 50 ampere. R, it is also given, it is 2.5 meter. It is mu 0, the value of mu 0 is not given in our board papers, but you have to remember. Of course, it's 4 pi into 10 is to minus 7. So by putting all these values, you will get the answer. B is equal to 4 into 10 is to minus 6 Tesla. Okay, this was the part 1. See, some students just write this thing, they think that they have solved the numerical and just leave it. But you will lose 1 or half mark due to this thing, because you have not written the magnitude. You have to write the magnitude, you have to write the direction also. So how to find out the direction? See, current is going in this direction. Current is going from north direction to south direction. So put your right hand thumb in this direction. This is called right hand thumb rule. If the thumb is going in this direction, then the direction of these fingers is the direction of magnetic field. So if we see at this point, at a distance of 2.5 meter over here, the direction of finger is like this, or we can see it is going in this direction. It is going in upward direction. So therefore, it will be perpendicularly outward from point P, or we can say vertically in upward direction. So this was all about essay 1, the part B, essay 1. In next our lecture, we'll see essay 2 type of questions. Thank you.